Here's what we are looking at. We are looking at limits approaching infinity. Now guys, when I give you these rules, they will only work if x is approaching plus or minus infinity. Typically what we're going to be talking about is we're going to be talking about f of x of a to the x raised to the m plus some sort of garbage, and b times x raised to the n plus some sort of something. Okay? And what we are ideally looking at here is we are looking at, if we have a graph, okay? There's my graph. My function, we really don't care what happens in the middle. What we are looking at is what happens on the end, okay? What happens on the end of the two things, okay? And ideally what we are looking at here is we are looking at just our lead exponents, or our degrees. We want to know which has the power, my numerator or my denominator, okay? So specifically we're looking at which exponent has the power. And keep in mind, we are only looking at the degree or highest exponent. So for example, on your rules, if my n is greater than my m, so let's look at this. If my denominator has the power, its largest exponent is bigger than the largest exponent on top, then my limit as x approaches positive or negative infinity will always be 0. Will always equal 0. Okay? Now, if they are equal, if my exponents share power, because they're the same, alright, my limit as x approaches positive or negative infinity, keep in mind there should be an infinity there, positive or negative infinity, will be my coefficients divided, a over b. Now, if my numerator has the power, and it's bigger than my denominator, my limit as x approaches positive or negative infinity does not exist. Okay? Moving on to a few examples. Alright, so my limit as x approaches negative infinity of 5x to the 3 halves over 4x squared plus 1. Now keep in mind, guys, you can only use this when we're approaching positive and negative infinity. Okay, so here, which one has the power? Which one has the largest exponent? Well, that'd be my denominator. Well, since my denominator is bigger than my numerator, or my exponent in my denominator and my numerator, my limit is 0. Done. Now, my limit as x approaches positive infinity of 5x squared over x plus 3. Well, in this case, which one has the power? Oh, my numerator. This has a degree of 2. That one has a degree, my denominator's linear. It has a degree of 1. Therefore, my limit does not exist, simply because the degree on top was bigger than the degree on bottom. Moving on to one more example. My limit as x approaches infinity of sine 2x divided by x. Well, in this case, I can't do anything with can't do anything with my exponents. You can't say 2. So what I'm going to look at is, let's look at the graph real quick. We know sine x over x is Cyclops. What's going to happen to that one? And this may not be a bad idea to memorize this. But as it approaches infinity, it gets closer and closer to 0. So that's your answer on that one. Okay. So what about my limit? Moving on, let's go to the next page. My limit as x approaches infinity of negative 3x plus 1 over the square root of x squared plus 1. Well, let's look at this. My degree on top is 1. Well, my degree on bottom is the square root of x squared, so let's talk about that. The square root of x squared, isn't that just in general? We can assume that that's x, correct? Alright, so my degrees are equal. Therefore, I'm going to use my coefficients of both of these. Well, my coefficient from my square root is 1. My coefficient in front of my x on top is negative 3. So it's actually my numbers divided by each other, negative 3 over 1, which is just negative 3. And that's my answer. Let's do one that's maybe a little more simpler than that. My limit as x approaches positive infinity of 4x to the 4th plus x over 3x to the 4th plus 2x. Well, let's look at this. Who has my power? Well, they're the same, so they share power. So let's look at my a and my b. It is just 4/3. Just a reminder, you have a test on Wednesday, and thank you very much.